ChatGPT doesn't think. It doesn't understand anything. It predicts the next word, over and over, billions of times. The question isn't whether that sounds too simple to explain language, medicine, law, and code. The question is why prediction at that scale ends up looking exactly like intelligence. Let's go all the way down to what's actually happening inside ChatGPT. Not the marketing version, not the science fiction version. The real mechanism. We're going to start with the most basic question. What does it actually mean to predict the next word? And end with why that simple process is probably the most consequential technology humans have built. Everything you type into ChatGPT gets broken into tokens, small chunks of text roughly the size of a syllable. The word unbelievable becomes 3 tokens. The word cat is 1. An emoji might be 4. When you send a message, ChatGPT doesn't read your words the way you do. It reads a stream of numbers, each one representing a token. Its job at every single step is to look at all the previous tokens and predict the most likely next one. Then output it. Then repeat. This is the full mechanism. There's no reasoning layer on top. No understanding layer underneath. Every response you've ever received was assembled 1 token at a time. Each chosen because it statistically followed what came before, right up to the last full stop. To learn which tokens follow which, GPT-4 was trained on roughly 13 trillion tokens. About half of all text ever published on the internet, plus books, scientific journals, legal documents, code, and academic papers in dozens of languages. If you read a novel every single day for 35,000 years, you might get through that much text. The training cost over $100 million and ran for months on thousands of specialized chips. The model didn't just read this data once. It was tested on it repeatedly, being corrected every time it predicted the wrong next token across the entire dataset. Multiple times. During training, the model is shown a sentence with the last word removed and asked to predict it. It guesses. It's almost always wrong at first. The error is measured precisely. How wrong? In which direction? Then the model's internal parameters, 1.7 trillion numbers called weights, are adjusted by a tiny amount in the direction that would have made the guess less wrong. This runs 13 trillion times across the dataset, multiple passes. By the end, the model has developed internal representations of language so detailed that it can complete sentences in Latin, explain quantum mechanics, and write working code, without being explicitly taught any of it. The capability emerges entirely from statistical pressure applied at enormous scale. But the model trained on the internet is not what you actually use. The base model just completes text. It's not particularly helpful or safe. What turns it into an assistant is a second phase called reinforcement learning from human feedback. Human trainers read hundreds of thousands of responses and rated them. A reward model learned what good looks like to humans. Then the base model was pushed through reinforcement learning to produce responses that score highly on that reward model. This is what gives ChatGPT its personality, its safety boundaries, its tendency to be helpful rather than just statistically correct. The product you use is the result of 2 completely separate training processes, one statistical, one human-guided, and you only ever interact with the second. The mechanism that makes the statistical part work is called attention. For every token the model is about to output, it looks back at every previous token in the conversation and asks, which of these are most relevant to what comes next? The word bank means something different after river than after money. Attention lets the model track context dynamically, weighting earlier tokens by how much they matter for the current prediction. This happens across 96 separate attention layers simultaneously, with each layer capturing different kinds of relationships between words. Before attention, language models forgot context after a few sentences. With it, a model can hold the thread of a 50,000-word document and respond as if it absorbed every word. The context window is how much text ChatGPT can hold in working memory at once. GPT-4 supports up to 128,000 tokens, roughly 96,000 words, about the length of an entire novel. Everything inside that window influences every output. But once something falls outside the window, it's completely gone. The model has no memory of it. This is why starting a new conversation means ChatGPT doesn't know who you are. It has no persistent memory outside the current session. What feels like a consistent personality is a property of the model's weights, not a stored self. Every time you open a new chat, you're starting from zero. So why does it sound like it understands you? because understanding and pattern matching at massive scale produce nearly identical outputs. If you've processed every human conversation about grief ever written down, you can predict what a grieving person needs to hear without feeling anything. If you've read every medical textbook, legal judgment, and engineering manual ever published, you can produce outputs that look exactly like expertise without possessing it. The model doesn't know what it's saying. It knows, statistically, what tends to follow what it just said. At 13 trillion tokens of training, those two things become almost impossible to distinguish from the outside. This is the real gap. A human who says the capital of France is Paris knows what a capital is, has a mental model of geography, understands nationhood as a concept. ChatGPT outputs that sentence because in 13 trillion tokens of training data, capital of France is followed by Paris millions of times. Same output, fundamentally different process. The human could reason about a hypothetical scenario where France reorganized its government structure. ChatGPT would complete whatever sounds most likely from its training and will be right most of the time because the training data mostly describes reality as it is. But the model has no mechanism to distinguish between what it knows reliably and what it's guessing. This is exactly why it hallucinates. When it doesn't have strong statistical patterns to follow, an obscure academic citation, a recent event, a highly specific fact, it still has to output the most likely next token. So it outputs something that looks like an answer, a plausible name, a confident date, a citation that sounds real but doesn't exist. It's not lying. Lying requires knowing the truth and choosing to say something else. ChatGPT has no concept of truth. It has probabilities. A response built on strong patterns and a response built on weak guesses feel equally confident because the model has no way to signal its own uncertainty. You cannot tell from the output alone whether it's reliable. And yet, it passed the bar exam in the 90th percentile. It scored in the top 1% of the GRE analytical writing section. It writes functional code in dozens of programming languages. It was never taught any of these things. Law, statistics, programming. These capabilities emerge from the statistical pressure of predicting the next word across every domain of human knowledge simultaneously. No one designed this. Researchers call them emergent capabilities, abilities that appear at scale and were not predicted by anyone. GPT-3 could not write reliable code. GPT-4 can. The architecture is almost identical. The difference is scale. This tells you exactly where to trust it and where not to. Anything that appears densely in its training data, standard code patterns, well-documented facts, widely discussed topics in multiple sources, it handles with remarkable reliability. Anything sparse, recent, or highly specific, niche academic papers, events after its training cutoff, precise numerical calculations, specific legal precedents, it handles unreliably and with identical confidence. The error pattern is predictable. It's not random. Use it to think through problems, draft, and iterate, explore ideas, generate options. Don't use it to verify facts, check citations, or calculate anything critical. Its strengths are exactly what you'd expect from a system that has read everything and understood nothing. ChatGPT is a mirror made of statistics. It reflects humanity's collective writing back at you in the shape of whatever you asked. Every answer it gives is built from the aggregate of everything humans have ever written about that topic, compressed into 1.7 trillion weights, decoded one token at a time. It doesn't know. It doesn't think. It completes. And that completion, done fast enough, at enough scale, trained on enough of us, turns out to be the most practically useful tool humans have ever built.